right, so we're going to start with an exploration on the computer, which I will just show you up front. The link is on Blackboard if you want to go in and click it just to look at it. But we're going to learn how to graph a parabola, okay? And we are actually not doing standard form, sorry. We're doing vertex form, okay? We're going to do vertex form, all right? And sometimes vertex form is called transformation form. Now, we graphed absolute values using transformation. So we're just going to write down, okay, parent function. And this is y equals x squared. And we will graph the parent, okay, y equals x squared, okay? And we will talk about what the transformation form does, okay? Vertex form. Vertex form is y equals a, and I'm only using a capital because the lowercase looks like a 9 sometimes, parentheses, x minus h quantity squared plus k. So you see some repeat of letters, A, H, and K. They will typically do the same thing all year. We just have to learn how that affects the different shapes of the graph. So what we're going to do is we're going to switch over to a little Desmo's interactive thing, and we're going to look at what the parent is and what A does. All I want to learn about is A right now, okay? Okay, and here we go. Here comes your graph. Here is what a parabola looks like. Okay, let's maybe zoom in just a little bit so we can see the points a little better. Okay, there you go. Look at my points. 0, 0, 1, 1, 2, 4. Notice that the purple point is the minimum. It's called the vertex. Okay, notice that there's 2 red points and there's 2 green points. Notice that they seem symmetric, right? I only labeled one of them because this point is because of the symmetry involved. All I'm going to do is change A, and we want to see if we can figure out what's going to happen. Okay, I'm going to go back. Think about what A would do when you learn to graph transformations the very first time. Right now I'm changing A by integers. They can change by anything. Notice that this is not a linear graph, so slope does not apply. There's a negative A. Let's go back to 1. Okay. What does A do to the graph? Anyone have a suggestion? No? Multiplies the y value. Okay, so let's think about what Noah said. Multiplies the y value. So let's do it again. A equals 1. A equals 2. Look at what values are changing. A equals 3. Now I put the original points on the board so we can compare. A equals 4. A equals 0. Okay, so he says A multiplies the y value. Can anyone describe what A does besides multiply the y value? What else does A do? Julia? Stretches it. Okay. Reflects it. Reflects it. What kind of A values reflect it? Negative. Okay, I'm looking for one more. A parabola looks like this. What if A was more than 1? What would happen to the parabola? Okay, give me a word that makes that happen.
Stretch.
Not stretch.
It's like
narrower or wider, okay? So let's look at A being more than 1. It affects how narrow the parabola appears, okay? If A, now I don't have fraction values, so let's see if I can adjust that, okay? Let's change by thirds, see if it'll let me do that, okay? Okay. Obviously, the points get a little bit trickier to find when you have fractions, okay? But look, as the A value goes, it's getting wider, wider, okay? Narrower or skinnier. Okay. Now you have your whiteboard, okay? So what I want you to do is draw your parent function on your whiteboard. If you don't have a graph, it's kind of okay. Just label those 3 points. Label the purple, red, and green point. Here they are. That's all you need. I'll even do it without a graph up here. Okay, so you're going to draw the parent function, which is this nice, we call this concave up, like a cup, because it's curved. It's not linear, it's curved. When your graphs are curved, we add this concave vocabulary to it. Concave up like a cup or down like a frown. Okay. All right, so all you need are these 3 points right here. 0, 0, 1, 1, and 2, 4. Okay. Can you graph y equals 2x squared? That's your parent. Can you graph y equals 2x squared? How would those points change? You can leave your parent on the graph. How would they change? Is it skinnier? Is it wider? Label the 3 new points. Now Noah told us that the A value multiplies the Y coordinate. So how are the points going to change? Draw it on your graph. Nice. Nice. Okay, you guys ready? 2x squared. I got skinnier. Okay, look at the points. This one went to here. 1, 2. The y coordinate multiplied by 2. The next one went here. 2, 8. Notice the symmetry. Okay? Notice that the y-axis goes right down the middle. Notice that the other point is just negative 1, 2. And negative 2, 8. Same distance from the center or the vertex. All right. The 2 value multiplies the y coordinate by 2. What are your points? 0, 0, 1, 2, 2, 8. Gets a little taller, gets a little taller. And symmetry. If this one is 1, 2, this one is negative 1, 2. A little narrower. All right. Can you do? I'm going to change the A value. Minus 1/2. You can do it. You can do it. See what you can do. Minus 1/2. Okay, there's your parent. What's gonna change? Minus 1/2. Wider, narrower. Label those 3 points and see if you can label the other points, right? Those symmetric points. See if you can label them. Stretching the parabola is the hardest thing to do, which is why we're practicing. Okay, nice. All right, let's look at what we get. Minus 1/2 x squared. Opening down like a frown. Concave down like a frown. Okay, let's scooch this up so we can see it. Okay, right here. -1, -1/2. Okay, 2, -2. All right, here comes the big question. What would another set of integer coordinates be? Give it a second, Noah. Find me a set of integer coordinates. Here's your equation. Y equals -1/2 x squared. You only have 3 points labeled. Okay? 0, 0. And then you have 2, -2. I would like another set of integer coordinates. What are you going to plug in for x so that you get integers for both x and y? Okay, 1, 2. I see 2 people have it. 3. Okay, if you have it, start sharing with the person next to you. Think about what you're going to plug in for x to get an integer for y. How'd you get it? Yeah, but which x stuff? 3. Nope, it's not 3 or 4 or 5. Which one will give you an integer for y? Okay, anyone have an idea? All right, Anna, what was your idea? 8. Okay, so here we go. I'm going to put up some more numbers here. 3, 9. 4, 16. Now this is the parent function, okay? This is just y equals x squared. Which numbers are going to be an integer when you divide them by 2?
Even numbers.
Multiples of 2 or even numbers. I don't want to do half of 9. All right, guys, when I ask you to graph a parabola, I really don't care which points you use. I would go for integers. Now, I'm going to ask for like 5 points. Notice how there's 5 points up here, but the vertex, right, the one in the middle, and 2 other points. That's it. And then I just reflected those points. So really, you're finding the vertex and 2 points, but you're going to make it into 5 points to get the shape. I would go for integer coordinates. Okay, so here we go. Let's go to your notes, and let's actually do one in the notes to see what we can write. Okay. Okay. Now, let's draw the parent function, and I'm going to write in a table of points that matches the parent. I'm going to start with 0, 0. 1, 1, 2, 4, 3, 9, etc. Perfect squares. And then I'm going to write the other side of the table also. Okay, and I'm going to draw my parent. Oh, 7. Oh, that's 9 up here. Okay. Nice nice and curved. Right, I'm only going to label half of them because the other half are symmetric. Okay, let's put our vocab on here. Axis of symmetry. Okay, in this case, it's x equals 0. Okay. We have a vertex. Vertex is right here. Vertex, which is the center of the graph. All right. And we've got our points. Okay, just a little reminder to ourselves. A, it stretches the y-coordinate only. Okay, so if A is positive, we're going to say up like a cup or concave up. Concave up like a cup. This graph is concave up. If A is negative, it is down or concave down like a frown. Means it's opening down. All right, H. What does H do to my graph? What did it do with absolute value and for our transformations from the last unit? Yep, right and left. Same thing, guys. Same thing. It's going to become pretty tedious. A, H, and K, same thing all year. H goes left and right, but it's opposite, right? It's opposite direction. Okay, what does K do? Up and down. Up and down. All right, so let's graph. F of x equals 2, parentheses, x minus 3 squared minus 8. Okay, here we go. How do I do it? Well, let's say what our transformations are. And I'm going to do them in order. Okay. I'm going to say concave up. I'll even put a little note to myself. Up like a cup. It's opening up because it's positive. A. Stretch by 2. Right 3, down 8. Got to move my graph. Right 3, down 8. That's going to give me my vertex of 3, negative 8. Okay, think about graphing your absolute value. Instead of having 2 linear pieces together, it's just a curved, concave up shape. All right. Now, if you have a pencil, maybe you just want to sketch your parent. I said maybe. I'm not going to sketch my parent every time. Okay? I kind of have to know where I'm going to start. Otherwise, I don't know what shape I'm moving around. Means this thing, this is something you have to memorize. You have to know the shape of the graph. That is something you have to know. All right. Let's move it. First, I have to stretch it. Okay, so that's going to go twice as high. 4, 1, 2, 3, goes up to 8. Okay. All right, it's like a halfway stage. I doubled my y coordinates. Now I'm going to move them. Right 3, down 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. And once I get my vertex, okay, vertex of 3, -8, I'm just going to look at the orientation of those points compared to the vertex, and I'm going to draw them. It was over 1, up 2, over 1, up 2. Because I don't want to get lost in my counting, so now I'm just orienting it based on my vertex. Now this one was over 2, up 8. 2, 2, 4, 6, 8. Okay. And axis of symmetry. Okay. Going to help me reflect my points. And concave up, nice and smooth. There is your graph. Okay, how did I do it? First, I determined the opening and the stretch. Then I moved my vertex. This is your graph, based off of the original parent points. Okay. Try another one. F of x equals minus 1/2 x squared plus 4. Make sure you can label your points. I suggest you go for integers. Okay, so the first thing I'm going to do is say concave down like a frown, because my A value is negative, and stretch, technically compress, by 1/2. And this is up 4, which means my vertex is 0, 4. Okay, now I could sketch my parent, but I don't really want to draw my parent every time. It gets a little messy. So instead, I'm just going to jot my parent points off to the side. And I'm only actually going to draw the positive points on the parent. 0, 0, 1, 1, 2, 4. I'm going to keep going on purpose. 3, 9, 4, 16, 5, 25. They're just the perfect squares. Input, output. Now, I'm going to highlight the points that I am going to use. Yeah, you can't not use the vertex. Okay? You have to have the vertex. Can somebody tell me why I only highlighted those? Or why did I leave off? Yes, Catherine.
Because you divide by, multiply by 1/2 and you have it saved.
Yeah. Guys, pick the points that work. If this were a 1/5 in front, I would probably only use this one and this one. Or if it was a 1/3, I would probably use the 3, 9 point. Plot the integers. Could you plot the other ones? Sure. But really, plot something that's actually easy to draw. Okay, so maybe you like a table. 0, nope, 2, -8. Okay, now I've got points that I can do this with. Up 4. Now keep in mind that these points are oriented from the vertex. Over 2, down 2. Make sure you actually have that in the right place. 2, -2, 0, 4. Over 4 from the vertex, down 8. 4, 4, 8. And symmetry. Symmetry is very useful. Yes, Sarah. Oh, sorry. Yeah, you're right. I totally meant to write the actual coordinates on the graph. I was busy saying down to. Okay, yes, you should write the actual coordinates. All this counting over here, that's just to get my points in the right place. And nice and smooth, guys. Nothing on this graph is linear. Nice and smooth, concave down like a frown.